Okay, so before I rack up here and go and move on to the rest of the design, let us show you what the daytime control look like. So that's what you're watching there. This is might be all over the place. So this is the daytime control here. We have, let me go back straight down here, go straight down to this area here. You will see we had a configure error. We have the PWM out A and B. We had a prompt, right, SDA, which is for the data itself. So we have everything here, right? So let us go to the end, right? So we had the clock coming in over here. We had a user config over here. We had a manual dead time. Now this bus is seen over here, right? We have 4 bits over here, right? So so our circuitry that I designed digital will be going in for the daytime select, that we select in the different combination, and then we have the sampling select over here, which is to determine the frequency of switching. So we can configure this one and that one, and then we have a reset, right? So the reset will disable the output, right? Manual config valid, and we have 1 megahertz clock here, right? So pretty much so the thing with this is that we have a clock over here 60 megahertz, and we have 1 megahertz over here. Now when you're doing your design, you will have to create a divider for what clock it is to make sure everybody in sync from 16 to 1, right? You could pretty much do those things, right? So this is that. So let us go to the next. Now this here is let's show you here, right? This is synopsis, right? Simplify, go, and then we have Questa. This is a different product, right? So this is Questa over here. Siemens purchase over this company, right? So yeah, so Siemens purchase over this company. When I say unpublished work, my library is work, right? This is finished in a sense. So anyway, Questa was meta graphics, right? So this one for simulation. The next one was for synthesis, right? Let me just compile everything. Right, this one over here, right? So it's written, right? Great. So let's run a simulation, and I will simulate. I make our audio amp over here, a test bench, so you can do everything that we would like to see do, right? And we click OK, and it's loading. You're going to be doing a sort of stuff, right? This is simulation itself. So the synthesis, the design itself that I have, right? This is my documentation, say 80 pages. So does have to document itself, right? And this is test bench, and the design itself, a bunch of files itself. This is hardware description language, so you're pretty much describing your hardware in a logical way, and this will synthesize into the schematic you see for analyzing it and see what's going on, and this will be synthesized. This could be simulation, run for simulation, and also be synthesized into transistors, right? When time for to do that. So now what we will do, let us run this for 100 microseconds. Just for 1 sec, because I would like to see I put 400 hertz as audio, right? So I have 400 hertz as audio, and I would like to see what the time 400 will be. The time period 400 hertz and 2.7 milliseconds. So let's put this at 10 milliseconds. right? 10 milliseconds. So we run this for 10 milliseconds, right? Right. So, okay, here was goes on. I have to open back this again. Um, right. Let me see. I was gonna comment this one out. Right. So let's save. Um, Nothing there. Nothing there. Right. And my dead time. Okay, so that's fine. So save and we compile back. Compile back all. And then we will run simulation. Right, what we're going to run, we're going to run this one here, right? Okay, let's jump across the side here, right? And I will send all these guys to wave, right? So we send to wave. Right, so let's dock this back over here. Now let's remove this for now. Move this, move this, remove this. So let's pull back this when we need it, whenever we need it. Right, so we will go to wave and let us pull this down here now, so you get more space there. And you run this for 10 milliseconds, right? And where is this here? Right, so this running for 10 milliseconds. Right, so I'm trying to show you already the frequency, the modulation going on. Right, so you can see it here, right? Right, so this is what the class D look like. So this one over here, we will consider this to be what? Right, so this is the EEPROM itself, right? And we had the PWM over here out. Cool. These are the 60 megahertz here, and this is the 1 megahertz here. Configure for, and this is the PWM over here, right? So you could see that. Let me zoom in right in. You can see they have a dead time control right over here. So this here, dead time control, right? So this is other information we can have for errors and stuff like that. We come down over here and you will see, right, um, count pass test. So they have information, but I'm not going to probably if I zoom in, zoom down over, right, right. So that is that. Put this up back there. I have to show you some stuff that's not. So anyway, let's go back down here back. Check this. Right. So this is where I want to show you what this thing look like. So we have like we inject an error, this one here, right? So let us say, okay, there's no error injected as yet, right? We just go back down here, right? Look at here. So this here now, let me say like the amplifier have a error somewhere, and when I say error, like the MOSFET going to blow, you know, you have a short, you know, something water falling here, I don't know what happened, right? So we have a reject error here. You notice the PWM is running all over here, right? And this is what I like to show. So when you're looking at the PWM running here, running fine, right? And I inject an error in the test bench, so I send an error here, and the both PWM it dropped to low. So the cycle over here dropped to low, and this here dropped to low too as well. So both gone to low. So the output of the IC goes to low when it have an error. Now we have a recovery now, recovery request. We send a recovery request and the PWM start back correctly. And when it start back correctly, it does not cause any infringement in the waveform itself. The dead time is maintained, right? It's off from this period, going straight here, right? And the PWM resume. Now the thing about this is that this is really good that we could have an error and we shut off the output so it won't cause damage, and when the error, you know, shut off, it put it back on exactly how it is. Now if you're using an amplifier now as a class A amplifier or a switch mode power supply, it depends on what you're doing, a motor drive or whatever. Sometimes you will like to resume back normal, fine, right? It depends on design, it's a robotic arm or something like that, and you want to resume back normal, you have to make sure the other signal condition resume back normal because you're probably engraving something. But if you want to soft start, then to have a jerk off in the design where music come back heavy, voltage surge back heavy, you know, robotic arm swing hard, you know, you can have damages like that. So you don't want to recover and end up surging something out. So when you actually have this here now, this error and this recovery, you whatever design you're doing, these signals here you could use, and you could pretty much get this and you shut down and you hold in memory in your design somewhere, right? If you want to hold the information, if you want to resume from the information, and when you recover, you could literally recover from the information itself, right? And instead you come back the original PWM may have wherever it is the signal coming from, you could have a soft start. You could demand a soft start. So this could start from soft going up. So, you know, it's that flexible in that sense. So this is your PWM over here all the time. Right? So let me see if I can get this to show. Right, so let me just show the PWM how it's changing in duty cycle. right? And if you notice, you're looking at these guys here, you notice the changing in the duty cycle itself, right? So probably when I zoom in like this, you can see um, something a little more better like that, I guess. Right, so now you're seeing how the duty cycle changing, right? So this is how PWM is actually look like, right? So you see clock there, everything there, lots of signal processing. So yeah, so that's it. Let's run this out. So this one is serious part where we recognize the shutdown, all the way going backward in time. But you should be able to see the actual shutdown that took place, right? You'll see a abrupt interrupt, right? So that is it. It went great. So now when you're looking at the PWM out here, you notice the kind of thing here, right? So we're looking at that, right? So we had to settle the logics itself, had to settle in itself, and then we gonna get clean logics coming out of it, right? So kind of important that when you're doing these things, you have to look at the time in your logic, something like that, and all that stems out. And the circuit for that, as I say, this is the circuit, right? So it is a large design, right? A very large design. Let me just kind of go back here, right, and scroll in. Right, so all that is processing happening there, right? That's it.